Each of our electronic devices is battery operated to avoid being constantly plugged into the main. It's well known. But do you know how the battery of your electronic tools actually works? To make it easier for you, here's a concise explanation of the redox phenomenon applied to your batteries.
Let's start with the chemical process of redox. It's a process based on the transfer of electrons between two oxidizing-reducing couples. Each pair is composed by a reducing agent, a chemical species able to give one or several electrons, and an oxidant able to capture them. During the operation of your battery, there is a transfer of electrons between the two couples. To highlight the transfer of electrons, we have produced an experiment device based on the redox couple of zinc and copper.
In order to create the solution of copper and zinc sulfate of concentration 0.1 mol per liter, we first weighed a mass of around 0.6 grams of each component. In a 100 ml vial, we've been mixing the powder weight with distillate water and complete to the gauge weight. Once our solutions were prepared, we were able to set up the device by first connecting the voltmeter and adding the solutions to their respective compartments. During operation of the batteries, a variation in the potential displayed on the voltmeter is observed, which indicates the creation of an electric current. Indeed, the battery is made up of two poles, a cathode, part where the reduction takes place, and an anode, part where the oxidation takes place. The copper couple constitutes the cathode while the zinc couple constitutes the anode. Once the battery is running, the Cu2+ is reduced to Cu, releasing electrons which will pass through the porous support to compensate for the loss of charge of the Zn, which oxidizes to Zn2+. After a while, the battery stops working. There is an accumulation of material on the copper plate and a decrease in surface area of the zinc plate.
This is exactly what happens in your phone, except that the materials present are not the same. You will find lithium and graphite. Electrons transfer keeps your phone on, and when the lithium plate is totally oxidized, you no longer have battery. The rechargeable battery model then appears. By plugging your phone into another electric, you will reverse the process by circulating the electrons toward the plate of lithium, which will then allow its regeneration. You think you can use your device infinitely? However, this reversibility process gradually damages the surface of the metal and prevents it from oxidizing properly. Your battery is nearing the end of its life. All you have to do is hit up the credit card.
Currently, researchers are trying to increase the life of batteries by turning into physics and quantum chemistry. In the meantime, other innovations are behind studies such as graphene bullet batteries, which would increase the current capacity, or solid batteries, which could then do without the electrolyte transmission system, which will be replaced by a supersonic conductor.